Hello students, welcome to lecture 2 of the solid state. Last class we have seen the characteristic properties of the solids. Then we classify the solids on the basis of order in the arrangement of constituent particles, and we got crystalline solids and amorphous solids. We have seen some 6-7 differences in crystalline and amorphous solids. The first one is in crystalline solids they have definite geometrical shape, whereas amorphous solids they do not have definite geometrical shape. Crystalline solids have sharp melting point. Amorphous solids they do not have sharp melting point. Crystalline solids they have definite heat of fusion. Amorphous solids they do not have definite heat of fusion. Crystalline solids and isotropic. Amorphous solids isotropic. Crystalline solids they undergo clean cleavage when they cut with knife. Regular cleavage. Planes are formed. Amorphous they undergo irregular cleavage. Crystalline solids called as true solids. Amorphous solids called as pseudo-solid or supercooled liquid. Crystalline solids they have long range order in arrangement of constituent particles. Amorphous solids they have short range order of arrangement of constituent particles. Then we have seen why glass is called as supercooled liquid, because it flows. In case of old buildings, we can see the glass panes are thicker at the bottom, and it can undergo partial crystallization also. Some milkiness dots are present in that glass pane of window of old building. So this part we have completed. Now today we will go ahead and we will see the classification of crystalline solids, because we are mainly interested in crystalline solids. So classification of crystalline solids, this is the part which we are going to learn today. Now this classification based on the constituent particles. Now what we mean by constituent particles in a solid state? By constituent particles we mean either the constituent particles can be molecules, or these constituent particles can be ions, or these constituent particles can be atoms. When we say constituent particles are molecules, the molecules again of three types. Some molecules we call them as non-polar molecules. Some molecules we call them as polar molecules, and there are some molecules which are hydrogen bonded. Hydrogen bonded molecules. Ions are only cations and anions. There is no further classification to it. But when we say atoms, there are two types. They can be the metal atoms, or they can be non-metal atoms. Right. So constituent particles are molecules. Molecules can be non-polar, polar, hydrogen bonded. Constituent particles can be ions, and constituent particles can be atoms, and atoms can be metals and non-metals. Now, when constituent particles are molecules and molecules are non-polar molecules, this is called as non-polar molecular solid. This particular non-polar molecules forms non-polar molecular solid. When the constituent particles are polar molecules, it is called as polar molecular. We will see the examples and properties. First we are learning how they are classified. Polar molecular solid. And when the hydrogen bonding molecules are there, we call them as hydrogen bonded molecules. Hydrogen bonded solid. When the constituent particles are ions, we call them as ionic solid. And when the constituent particles are metal atoms, we call it as metallic solid. And when the constituent particles are non-metals, we call it as covalent or network solids. So this non-polar molecular solid, polar molecular solid and hydrogen bonded solid together, they are called as molecular solid. So we have four types of crystalline solids. First is molecular solid, second is ionic solid, third is metallic solid, and fourth is covalent or network solid. So what are the types of crystalline solids? Molecular solids, ionic solids, metallic solids, and covalent or network solid. Why we have these four different types of crystalline solids? Because the solids are made up of different constituents, and depending on what they are made up of, constituent means the particles by which they are made up of, we have these four types of solids. Now every crystalline solid is different from one another in constituent, binding force, melting point, conductivity, and its hardness. And we have to see example also. So we'll see one by one type of these crystalline solids. We start with the molecular solids. So question can be asked to identify the type of solid. So you should be very alert in listening these points. So first we are learning is the molecular solids. There are three types. Just now we have mentioned them. One is non-polar molecular solid. Another is polar molecular solid. And third is hydrogen bonded solid. Right. Now first is the constituents. What are the constituents present in non-polar molecular solids? The constituents are non-polar molecules. Non-polar molecules. What are the constituents of polar molecular solid? Polar molecules. Right. And what are the constituents of hydrogen bonded solids? molecules having hydrogen bond. Now what is the hydrogen bond? We'll see in the binding force. The next point will be the binding force involved in this type of solids. Non-polar molecular solids involves weak, we call it as London or dispersion force. Polar molecular solid involves dipole-dipole interaction. We have learned these words in last year's states of matter. And hydrogen bonded solids, they involve a kind of covalent bond between hydrogen and more electronegative elements like fluorine, oxygen and nitrogen. We will call it as polar bond. A kind of polarity exists because hydrogen is least electronegative, fluorine is more. So fluorine has negative 4, partial negative charge, partial positive charge, partial positive charge, partial negative charge, partial positive charge, partial negative charge, like that. So this is the binding force involved in all these solids. Third one, we can say that they are soft. There is no hardness involved into them. They are very soft in nature. Fourth is they have low melting point. They have very low melting point. And melting point of polar molecular solid is greater than non-polar. And melting point of hydrogen bonded solid is greater than polar molecular solid because hydrogen bond is stronger than the dipole-dipole interaction, and dipole-dipole interaction is stronger than London or dispersion force. Then fifth point, we can say conductivity. Whether they are able to conduct electricity or not. So answer is no, because they won't have free ions or electrons in them. So it is insulator. Insulator means they won't conduct electricity. Now the next point after the conductivity is the physical state at room temperature. Right here only. Physical state at room temperature. So as very big forces involved, they are either liquids or gases. In case of polar molecular solids also, liquids or gases. And in hydrogen bonding, you can say that either they are soft solids or liquids, because hydrogen bond is relatively stronger. Now, last is example. Non-polar molecules, we can do example of noble gases. Solid argon or solid iodine, because iodine is non-polar. This is iodine, same electronegativity, no poles. It is non-polar. In case of polar molecular solid, we can give the example of solid HCl or solid SO2. Because all we are learning crystalline solids, that's why word solid we are using. For hydrogen bonded, solid H2O, which is nothing but ice, And then another example we can give is solid ammonia, because ammonia also involves hydrogen bonding with it, right? So what are the constituents? What is binding force? Whether they are soft or hard, melting point, conductivity, physical state at room temperature, and the example. So this very simple description, you can go through it, try to understand. The words which we are using here are already known to us. This London force is weakest force. Dipole-dipole interaction is stronger than that. Hydrogen bond is nothing but stronger dipole-dipole interaction, because hydrogen is least electronegative, and oxygen, fluorine and nitrogen, they are more electronegative. And then this properties. So this is about the molecular crystalline solid. Now next type of solid which we learn is the ionic solid. Ionic solid. Once again, the same points we have to learn. The first point is constituents, what it is made up of. Next is binding force, what bind those constituents. Third is whether they are soft or hard. Next is whether they conduct electricity or not. And then example, and then melting point. So second type of solid we are learning now is the ionic solids. We can say constituents of these ionic solids are cations and anions. Next point, when we talk about its binding force, we call it as Coulombic or electrostatic attraction, because they have Coulomb charges. So it is electrostatic attractive force, which we call it as ionic form. Third is, we can say they are hard and they are brittle, means they can easily break. And then fourth one is their melting point. You can say they have high melting point because very strong force of attraction exists between cations and anions. Fifth point, we can say that they are insulator in solid state. Why? Because ions are not free to move. They are bonded by this electrostatic force of attraction. So they are insulated in solid state, but they are conductor in aqueous and molten state. Why is so? Because we can say ions are free to move about and they can carry the electric current. They can discharge at opposite electrode. And in that process they carry the current. Sixth point, we can say that example of this type of solids are sodium chloride, magnesium bromide, then we can say zinc sulfide, magnesium oxide. Many examples. The examples of all ionic compounds, we can say that they are nothing but ionic crystalline solids. So constituents are ions, which are cations and anions. Binding force is ionic bond, hard and brittle. high melting point. Insulator in solid state, but conductor in aqueous and molten state. And these are examples. What is their physical state at room temperature? They all are solids, isn't it? It's not like that. In case of molecular solids, they are liquids and gases. Why to decrease the temperature, and then we can solidify them. It's not case with the ionic solids. Already bond is so strong that they exist in a solid state at room temperature. So this is about the ionic solids. These 3-4 points we need to remember. Then next is the metallic solids. Metallic solids. Metallic solids. Third type of crystalline soluble energy. The first point is, of course, the constituents. Regarding constituents, we should know that metals, due to their high atomic size, they have very low ionization enthalpy, and that's why they can lose electron easily, and they can form positive ions. These positive ions we call them as fermions, and valence electron, they leave that metal if energy is supplied, and this is called as mobile electron, which is delocalized. Delocalized means it is property of 4 metallic crystal. It does not belong to only one metal atom. So it moves about. That's why we say that metals are good conductors of electricity. They can conduct heat also. That's why they are good conductors of heat also. So constituents are positive charge surrounded by C because they are distributed, C of delocalized electron. What type of binding force exists in them? We say that binding force is metallic bond, which is the force between this positive charge and mobile electron. They are hard, they have luster on them, they are colored, they are ductile, and they are malleable. All these luster, color, ductility and malleability. Ductility means we can draw thin wire out of them. Malleability means we can hammer them and convert into thin sheets. This is due to delocalized electron. Low to high melting point. Some metals have very high melting point, some metals have very low melting point. Just like gallium has low melting point, but tungsten has very high melting point. So there is range in melting point. Good conductors of heat and electricity. In example, we can say gold, silver, copper, brass, bronze, alloys. So these are the metallic solids. Very simple. The constituents are positively charged ions surrounded by C of localized electron, delocalized electron. Delocalized means which are moving. Binding force is metallic bond. Hard lustrous, colored, ductile, malleable, low to high melting point, to conduct of heat and electricity. These are the examples. So this is about the metallic solids. Now last type of crystalline solid is the covalent or network type of solid. So fourth site in this type of crystalline solids is covalent, also called as network solids. Now what are the constituents? We say constituents are non-metal atoms. What is the binding force? Binding force is strong, very strong. Covalent bond. And this covalent bond is directional. Remember, ionic bond is non-directional. But covalent bond is directional, that's why we get various shapes to the covalent molecules. Trigonal, planar, tetrahedral, pentagonal. These all shapes are due to their directional character. And it exists as giant molecules because of this strong covalent bonds. That's why they are very hard and they have very high melting point. They are very high melting point. They are insulators because there is no ions and there is no free electron. But there is exception. Is of graphite, which is soft as well as conductor of electricity. You see why it is so. 6 point. Look at the example. They are very typical and they are very few. Silicon oxide, quartz, silicon dioxide, silicon carbide, carborundum, graphite or aluminium nitride. Aluminium nitride also comes under this covalent network solid. Graphite and diamond. Only these 4 or 5 examples you have to remember. Now we'll see why graphite is soft and conduct electricity. Consider the diamond. It has this carbon atoms, tetrahedral arranged and network is there. So it has no free electron. That's why it is insulated. No free, all electrons are inward, 4 covalent bonds. 1, 2, 3, 4. For this carbon, 1, 2, 3, 4. For this carbon, 1, 2, and it is again a kind of network is there. No free electrons, so it is insulated. And strong covalent bond. That's why it is very hard. Right? It's about diamond. For graphite, the structure you are learning in the first year. These are the hexagonal rings. These are the carbon atoms arranged in this hexagonal rings. Right. And these two layers, it has weak van der Waals force. The layers are bounded by weak van der Waals forces. Because of that, layers can slide, slip, layer can slip, and that's why it is used as lubricant. This bond is very strong covalent bond. That's why it has high melting point. But this carbon, it forms only 3 covalent bond. So fourth electron is delocalized. Fourth electron, carbon has 4 valence electrons. Out of 4, only 3 are utilized. So the fourth electron is delocalized in these layers. That's why it is a conductor of electricity. Right. So why graphite is conductor of electricity? Because every carbon atom in graphite crystal has free, mobile, delocalized electron responsible for conductivity. Why diamond is insulator? Because no free electron are available for the conduction of electricity. Why graphite can be used as lubricant? Because it has hexagonal rings in 2 layers which are bonded by weak van der Waals force. 2 layers can slide and it can minimize the friction, and that's why it is lubricant. Why graphite has very high melting point? Strong covalent bonds are present. So it has strength in the form of covalent bonds, and it has weakness in the form of van der Waals force. So the both contradictory characteristics are present in graphite. And why it is conductor of electricity? Because it has delocalized the electron. So these are the few properties of the covalent, also called as network solids, which exhibit as the giant means network, large network of non-metal atoms. That's why they are very hard and they are very exceptionally higher melting. So this is all about the all crystalline solids. Now we have to solve some questions based on it. The questions, there are 3 types. One is in-text question, exercise question, and solved question. We have list of those questions. I will just read the question and the answer, and whenever we need to write, I will write on the board. So first in-text question is, why solids are rigid? The answer is due to strong intermolecular forces. I will not write on the board. Again, it will take time. So you can just listen it again and again. You can reduce the speed of this video and you can make notes of it. Or if you have your own textbook, you can write with pencil the answer. Why solids are rigid? Due to strong intermolecular forces, solids are rigid. Why do solids have definite volume? Solids are rigid and incompressible. That's why solids have definite volume. Classify the following as amorphous or crystalline solid. So this question we need to write. Classify the following. Classify the following as amorphous or crystalline. kind of plastic, so it is amorphous. Naphthalene, which is aromatic compound, it has sharp melting point, so it is crystalline. Next is benzoic acid compound, fixed melting point, so crystalline solid. Next is Teflon, kind of polymer, no sharp melting point, amorphous. Next is potassium nitrate. Potassium nitrate. We know that this is ionic type of crystalline solid, so it is crystalline. Then comes cellophane, kind of polymer. That's why it also comes in amorphous. Then comes polyvinyl chloride. Polyvinyl chloride, plastic polymer, so it is amorphous. Then comes fiberglass. Fiberglass, glass is an amorphous solid. And then comes copper. Copper is a metallic crystalline solid. So polyurethane is amorphous. Naphthalene is crystalline. Benzoic acid is crystalline. Teflon is amorphous. Potassium nitrate is crystalline. Cellophane is amorphous. Polyvinyl chloride is also amorphous. Fiberglass is also amorphous. And copper is crystalline, of course. This is all solid, right? So very simple question this was. Next question is, why glass considered super cooled liquid? So glass is a super cooled liquid because, like liquids, it has tendency to flow and undergo partial crystallization. That's why it is considered as super cooled liquid. Refractive index of a solid is observed to have same value, isotropic, amorphous. Comment on this solid. It is amorphous solid. Would it show the cleavage property? It undergoes cleavage with irregular planes, right? So no clean cleavage into it. Solid A has very hard. Solid A is very hard electrical insulator solid, as well as in molten state and melts. Insulator is solid as well as in molten state. Melts at extremely high temperature. What type of solid it is? Very hard insulator in solid and molten state. Extremely high melting point. Covalent solid, isn't it? Ionic solids conduct electricity in molten state but not in solid state. In molten state, ions are free to move about, and in solid state they are not free. Which type of solids are electrical conductor, malleable, ductile? I think you know the answer. It is the metallic solids. Define the term amorphous. Give example of amorphous solid. Amorphous means those solids which do not have definite geometrical shape. Example: glass, food, plastic, starch, protein. What makes glass different from a solid such as quartz? Under what condition quartz be converted into glass? Glass is an amorphous solid and quartz is a crystalline solid. Yes, I would. Covalent solid. Quartz can be converted to glass by melting and rapid cooling. Because if we cool it slowly, it becomes crystalline. Rapid cooling, it have random arrangement and it can be amorphous. Classify the following solids as ionic, metallic, that I will give you as homework, and difference, similarity and differences between metallic and ionic crystal. You can see the properties and you can distinguish between them. Why ionic solids are hard and brittle? Because ionic solids have strong coulombic or electrostatic force of attraction. So I will give two questions as a homework here. Let's see how you do that homework. Even though I have just orally explained question, they are very important because they have been in textbook. So don't ignore it. You can just read it again and again, or you can watch this video by pausing and again you can revise it. But these questions are important. So what two questions I am giving you as the homework here. The first is classify the following solids based on nature of intermolecular forces operating between them. So instead of writing question, I write here compound, and here I will write intermolecular forces. You have to identify. So this column I will write and this column you have to complete. For example, a potassium sulfate. Which type of bond is present? Ionic bond. That you have to write here. Electrostatic attraction, like that. Then tin. Tin is a metal, metallic bond. Then benzene is a hydrocarbon. London forces exist into it. Then comes urea. I will not tell you. You have to write this. Urea. Then ammonia. Then water. Then zinc sulfate. And then graphite. And then rubidium. Argon. And silicon carbide. So I write these intermolecular forces. What are the intermolecular forces? We deal with. First is London force present between non-polar molecules. Then dipole-dipole interaction present in polar molecules. Then hydrogen bonding present in hydrogen bonded molecules. Then ionic bond, then metallic bond, and then comes covalent. So out of these 6, any one is present, and that you have to write. I hope that you write it correctly. And one more question which I am planning to give you as homework, that classify each of the following solids. Classify each of the following solid as ionic, metallic, which is nothing but network, metallic, molecular is not network or covalent or amorphous. Maybe some of the examples are of amorphous. So first is P4O10, second is ammonium phosphate, third is carborundum, which is nothing but silicon carbide. Fourth is iodine. Fifth is phosphorus. Sixth is plastic. Plastic is amorphous. Graphite, brass, rubidium, lithium bromide, and silicon. So this is the 2 questions I have given you as the homework. First read the notes or your own notes which I have written on board or printed notes, and then solve these questions without referring notes and see how many of these you can able to classify it. I will explain the answers in the next class. So thank you for watching this video.